All right, here we go with the t-test, and this is a 10.3. Make sure, yep, 10.3 in our textbook. Oops. Okay, and so here's the setup. Here's an example we're going to look at. A news reporter said the average price of gas in California is $4.45 per gallon. I think it's lower, so I took a random sample of 50 stations and got an average of $4.40 per gallon with a standard deviation of 20 cents a gallon. Is this evidence that the true average price is less than $4.45 per gallon? That's what I'm asking, because they said it was $4.45 and I don't think it is. So what am I going to do? I'm going to take a sample. And the question is, well, I took a sample and I got $4.40. So the question is, did that $4.40, could the average be $4.45 a gallon and I just happened to get 50 stations whose average is $4.40? Or is that evidence that no, the real average isn't $4.45, it's less, it's like $4.42, $4.43, something like that, right? So the question is, did my sample, okay, so could I get this by chance? When mu equals $4.45. Right? And that's what we're going to find out, is could I get this by chance? If it got it by chance, then I got no reason to question the $4.45. If it isn't likely to happen by chance, then we ask the question, why did this happen? And maybe the reason is it's because, it's really less than $4.45. Okay. All right. So let's go ahead and attack this. And if you're not clear on the theory behind a test, a hypothesis test, that's what these are called, then go check out the one proportion z-test. I did a quick little summary on that, not great detail, but enough that I think it should get you dialed in between that and what we do in class. All right, so let's go ahead and take a look here. We're going to do what's called a t-test, a one sample t-test. And I'm going to assume H0, that's my null hypothesis. I'm going to assume that mu is equal to 4.45, and I want to show that mu is less than 4.45, or that's what I'm hoping to show. And so let me just make a little note on the side here. This is the null hypothesis, and this is what we assume is true. This is the alternative, and that's what we want to show, hopefully. Okay. Step one. Step two, we check our conditions. Well, the conditions to do any sort of a t-test is the ones we're interested in right now is that it has to be a random sample, and secondly, we used NP and NQ bigger than 10, but the question is, what is it that makes this distribution approximately normal, the X bar distribution? Well, what makes that normal is n being bigger than or equal to 30. That's the central limit theorem. Okay. And if that's not the case, then we could look at, or if the population is normal, then this would be approximately normal as well. Step three are the mechanics. So what we're really doing in terms of mechanics is we're saying, let's look at my t-curve, where the mean, we're assuming it's 445. And the standard error, it's the standard error, not the standard deviation, because we're using S divided by the square root of n. My sample standard deviation is 0.2 divided by square root of n, square root of 50. And what we're really asking is, my sample is 445. My sample's down here, or I'm sorry, my sample's 440. How likely is it that I get that sample? Right? What's the probability that X bar is less than or equal to 4.40? Just by random chance. Just if I happen to pick 50 stations, the average is still 445. Could that happen, or is that not very likely to happen? Because it did, because that's what I got. That's what I'm telling you I got. Well, we can figure this out by calculating the t-score. And that would be 440 minus, it's just like the z-score. And I can do that, and then I can look up on a table and figure out roughly what this p-value is. But what we're going to start doing is using our calculator. Remember, the p-value is the probability of getting 440 or less. Okay, so let's take a look at our calculator here. Okay, so we're going to do this whole test on our calculator, and the reason, let me put this down here. I'm going to go to Stat and then over to Tests, and there's a list of tests here, and we're doing a one sample t-test. That's why I want to make sure we label it. So I'm going to scroll down to a t-test. In this case, it doesn't say one sample. Sorry about that. Get out of my way. And it's t-test. My input, I want to put in stats because I'm putting in actual stats. So mu0 is H0, 4.45. Oops, I don't know what I just did there. Stat, test, t-test, enter. Oh, I got to move the cursor down there. 4.45. That's my H0. X bar is my sample. My sample was 440. And my standard deviation was 0.20. And n is 50. I took 50, right? Yeah. So this is just me putting in all of my data. Because remember, my sample was this. X bar was 440. S was 0.2 and n was 50. And now this bottom one, I'm doing less than 445, so I need to move my cursor to the less than. The mu0 is 445, so this says less than 445, right? This next one would be greater than, but I want less than. Calculate. And so this gives me my t-score, negative 1.76. When I write on my screen, the calculator goes away, negative 1.76. And my p-values, move the decimal over 2, or is 0.042. 0.042, which is, of course, 4.2%. All right, so now we have to ask ourselves, what does that mean? Well, again, that means, oh, the likelihood of me getting 440 or less will happen 4.2% of the time. Could that just happen? Did it just happen by chance? Well, it could, but is it likely? Well, what do we use for our criteria or our cutoff for likely? We use 5%. So for my conclusion is we're going to say since the p-value 4.2% is less than 5%, I have evidence that the true average gas price in California is less than 4.45. Okay, per gallon. So we're saying because this didn't happen by chance, why did it happen? Well, it happened because my original assumption here of 4.45 is too big. Okay, it's got to be smaller. Okay, so this is my one sample t-test. And let's go ahead and do a little bit of bonus on here. I know it's crazy, huh? Bonus math. I want to estimate, I want to range for just how, what is the actual gas price per gallon? Because I don't know. I just know it's less than 4.45. That's all the hypothesis test tells me. It doesn't tell me anything more than that. So let's go ahead and do this. Let's find, make that a little thicker. Find a, let's do a 90. 90%. I'm running out of, I don't know. It's getting tired or something. Find a 90% confidence interval. For mu, the average price in California. Okay. Well, step one, we're going to do a T interval. Sorry about my pen on here. Step two, conditions. Okay, those are the same conditions as up here, so we're good. So conditions, see above. 3, for my T interval, it's x bar plus or minus T star S over the square root of N. So it's going to be 440 plus whatever T star is times S 0.2 over the square root of 50. Now, do you remember how to find T star? We did that on the interval for the T interval. So I'm going to go up. We're doing a 90% confidence interval. So I'm going to look up here at 90%. That's this column. And remember, degrees of freedom is n minus 1, so it's going to be 49. 50 minus 1 is 49. And I'm going to come over here and look up 49. And it's not here. So I want to go to the, it's somewhere between these two, right? So you always use the bigger number, okay? So you're always going to use the bigger one. You're going to go up the table. So I'm going to use 1.684. So T equals 1.684. So I'm going to go 1.684. And I can calculate that. And let me show you how to do it on the calculator. Go to stat, tests, one sample T interval, or maybe it just might, oops, it's just this T interval. So T interval, enter, and then I put my sample in, 4.40. Oh, it kept my data from the other t-test we did, 0.250, and I said a 90%, didn't I? Ooh, is that what I did up here? Did I do 90% up here? Yeah. Okay. 90, calculate. And my interval becomes 435, 445. 435, 445. So we'll say 4. I'm 90% confident that the true gas price in California is between $4.35 and $4.45. So it's between those. It's not equal to 4.45. So that kind of matches what we found up here. So it's somewhere between those. So it doesn't tell me exactly because I can't do it exactly, but I can give you an interval. But what can I do to make my interval smaller? What makes my margin of error, that guy that I'm adding and subtracting, smaller? Well, if I make n bigger, so if I did a sample of 100 or 200 gas stations, that would make my interval smaller and my estimate would be more accurate. Alrighty, there you go on t test and a t interval. Okay, and if the theory behind it isn't clear, go check out the one proportion videos, and that has a little more detail on the behind the scenes stuff. All right, there you go.